So recapping what was on the last page, we are revolving about the y-axis. So I have a vertical axis of rotation, which means I want to use dy and have my equations all in x equals. I drew my radii perpendicular to that spin axis so that I could see them. And because I want my equations in x equals, I'm using 1 over the square root of y minus 0, x equals 0. Those were my two x equals equations. And my values for y, since I'm integrating with respect to y, go from 0 to 4. So now when I integrate, remember we're doing pi radius squared, I get natural log of 4, since natural log of 1, of course, equals 0. So on problem 2, I've already rewritten my equation so that I can graph it. Instead of x equals y squared, we have x equals square root of x, and you can see in the picture that's the black curve. I've also graphed y equals 0, which would be a horizontal line on the x-axis, as it intersects my black curve, so you really can't see much of anything there. And I've also graphed y equals 1 in red, and I've graphed the y-axis as x equals 0. I've also drawn in my radii perpendicular to my spin axis, which is x equals 1. And so therefore, since I have a horizontal spin axis, I'll be integrating with respect to x, which means I want my equations to be in y equals. So that means my radius will be top minus bottom. The top curve is the red one, which is 1, minus the black curve, which is square root of x. And I'm going to integrate my equation to find volume, which remember is pi times the radius squared. Looking at my graph, of course, the lowest y value that I can have is 0, and the highest y value, the lowest x value I can have is 0, and the highest x value I will have is 1, because of course it intersects out here at 1, 1. And so when I FOIL this out, I get 1 minus 2 squared root of x plus x, and then of course integrating and substituting in both 1 and 0, I end up with pi over 6. So I have a vertical spin axis, which means I want to use dy, and therefore I want my equations in y equals. As you can see, I've already graphed it, and I've shaded in the region, the bounded region, and drawn my spin arrow so I know which way I'm spinning it. So now I want to find my radius, and I'm using x equals. That means I'm going to have to solve this first equation for x equals. So as you can see, I've solved it. X equals cube root of y, and I want right minus left. So right is the black curve, which is the cube root of y, and left is the orange curve, which is x equals 0. Of course, that simplifies. And now I'm ready to integrate. So I've used my formula, volume equals pi radius squared times dy. And I'm looking at the values for y for my bounds. So the lowest value for y is 0, and the highest value for y is 8. So when I integrate, I get y to the 5 halves, of course, divided by 5 multiplied by 2, and of course I have to substitute first in 8 and then 0 to get. Oops, probably caught that mistake, should have been to the 5/3. Now substituting in 8, I get 32, and of course substituting in 0, I'll get 0, which gives me a grand total of 96 pi over 5.